Okay, this is now November 2007. Paper 3H, first 10 questions. Let's go. As normal, you've got your formula sheet. That's the same formula sheet as every single paper that you'll ever get. Um, just as a quick reminder, things which are actually going to be useful, definitely this one, Pythagoras' theorem, all of this trigonometry stuff, that's very important. Easy marks as well. You got your basic things: area of a circle, circumference of a circle, volume of a cylinder, quadratic equation, also very useful to get some easy marks. Okay, let's start here. I've got the calculator to hand. It says the diagram shows a regular five-sided polygon with center. Oh, so that's a pentagon. So I know that all of these angles added together is going to be 360 degrees because the angle's in one rotation. And because it's a regular five-sided polygon, that means that all of these sides are exactly the same, which means all the angles in the middle are also exactly the same. So I'm going to work out 360 divided by 5, which is 72. Okay, so that means one angle in the middle is 72. They're all going to be 72. Now that also means I can work out x. Because it is a regular polygon, I know that this angle here is also going to be x. And I also know that if I take those angles together and I do 72 plus x, that's going to equal 180 degrees because the angles in a triangle add up to 180. So 72 plus 2x, that equals 180. I can now solve this equation. Minus 72, I get 2x equals 108. 180 minus, that's brain's not working. Yep, good. And then I can just divide by 2, slowly peeling that onion, and I get x equals 54. Okay, so I've worked out x. I'm just going to carry on working out y as well, because I know that that's x, and similarly that I know that this angle here is x, here is x, but because these are all the same triangles, it means that this angle here is also x, and this angle here is also x. So I also know that to work out y, I'm going to have x plus y, and that's going to equal 180 because it's the angles at a point on a straight line. So those added together, that's going to give 180 degrees. So I've got x plus y, so that's 2x plus y equals 180. Well, we know what x is, don't we? It's 54. So that's going to be 2 times 54 plus y equals 180. And that's 108 plus y equals 180. And then we can just do y equals 180 minus 108, which is 72. Okay, so y equals 72. Right, let's go to the next question. Right, the table shows information about the scores in a game. Work out the mean score. Okay, so these are, we're missing a piece of information really here. We can do this the old-fashioned way. We can do this the really straightforward way. And what this means is that the number of games that were played, the score in each game was different. The total number of games played would have been 5 plus 8 plus 3 plus 4. Okay, so that I think that's going to be 12. I think that's 20 games. Okay, so what does that mean? That means in the first game, the person scored 1. Or let's put them in order. One game, they scored 1. another game they scored 1, another game they scored 1, another game they scored 1, another game they scored 1. And then in 8 games, they scored 2. So I'm just writing out the data. 1, 2, 3, 4, 5, 6, 7, 8. And then 3, 3, 3, and then 4, 4, 4, 4. Okay, so that's writing out all the data, the old-fashioned way, the long way, if you will. And what I want to do is work out the mean score. And so remember, if we're working out the mean, we add to work out the mean. We add everything, all our data, then divide by the number of pieces of data. Now, if I want, I can put this into the calculator. 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2, etc., etc., etc. Or I can just do this. Well, that's 5 times 1. That's 8 times 2. That's 3 times 3. And that's 4 times 4. And that's a lot easier to work out. So next to here, I'm actually going to draw an extra bit of table because they never include this. They never include this part of the table, but you can do it. And I'm going to do score times frequency. So 1 times 5 is 5. 2 times 8 is 16. 3 times 3 is 9. 4 times 4 is 16 as well. And I'm going to add them all together. 5 plus 16 is 21. Plus 9 is 30. Plus 16 is 46. And if I'm dividing by the number of pieces of data, well, I already know that there are 20 pieces of data. So it's going to be, I'll write it out here, what I would put in my calculator, 5 times 1 plus, or what should I do? Let's do it this way instead. I'm going to do 1 times 5 plus 2 times 8 plus 3 times 3 plus 4 times 4. All over 5 plus 8 plus 3 plus 4. And that's going to give me 46 over 20, which I can put in my calculator, 46 over 20. And that's 23 over 10, or 2.3. Okay, done. 3 marks. Right, next question. A triangle has 2 equal sides of length 2x and 1 side of length x. Okay, the perimeter of the triangle is 12 centimeters. This is very similar to the one we saw in, I think it was the previous one, June 4H, I think it was. So we've got the perimeter of the triangle is 12 centimeters. Use this information to write down an equation in x. Okay, so we've got the perimeter, that's all the sides added together. So 2x plus 2x plus x equals 12, because it says in the question. How many x's have we got? We've got 5x equals 12. So x equals 12 over 5, which is 12 over 5 is 2.4. Oh, whoops. So sorry, I've done that wrong. That's my equation, okay? And solving my equation should be down here. I've got 5x equals 12, divide by 5, and I get x equals 2.4. Now, this is an interesting question. I could also think that if this were a different question, they wouldn't give you that length, and they would include an extra word here. They would say an isosceles triangle has sides of length 2x and x, and then you would have to be able to work that out, because you'd know that's 2x and that's x, and it says work out the perimeter, but you don't get given that. But because it's an isosceles triangle, you can infer that that also is 2x. Okay. Let's move on. Number 4, the total number of students in Denton College is 280. 160 of the students are in year 1. Express 160 as a percentage of 280. Okay, so this is going to be of the 280, out of 280, 160 people are in Denton College. So this is just a fraction. 160 divided by 280 is 4/7. As a decimal, that is 0.571428, blah, blah, blah. Okay, now remember from fractions to percentages or decimals to percentages, everything after the point right there, that's your percentage. Okay, so essentially what we do, we times this number here by 100. Okay, and that will give you the percentage. So this is 57.1428 ... percent. But it asks you to give it to two significant figures. Okay, so two significant figures are, this is my first significant figure, my second significant figure, and then I look at my next figure, and because that's 1, it's going to round down to 57. So the answer is 57%. Number 5, calculate the area of a circle of radius 2 meters. Circle, 2 meters. Area is pi r squared. Okay, if you don't have to remember that. You can find that on the formula sheet. Where is it? Where is it? There it is. Area of a circle, pi r squared. Super easy, super simple. Pi r squared, r equals 2 pi times 2 squared equals 4 pi, which is on your calculator 4 shift, and then it's right in the middle at the bottom, pi. Now it gives, your calculator actually should give 4 pi as the answer, but you've got to convert that to decimals. It says to 3 significant figures. It says here's 12.566. Now to 3 significant figures, that's 1, 2, 3, and then I look at my fourth one, that's a 6. So this bit here is going to, this third one here, that's going to round up. So my answer is going to be 12.6. And that's my answer for that one. A circular pond has a radius of 2 meters. There is a path of width 1 meter around the pond. Calculate the area of the path. Okay, well, the area of the path is going to be the area of a circle, and that's going to be the area of the big circle minus the area of the pond. Okay, just go and do another one. Go. Sorry about that. Okay, so we got a big circle. Oh, that's nice. Oops. Yeah. Right, we've got a big circle, and that's radius 3 minus the slightly smaller circle, radius 2. Well, we've already worked out the radius 2 one, so that's nice and easy. So radius 3 is going to be pi times 3 squared, which is 9 pi. 9 pi is 28.274. To 3 significant figures is 28.3. And now we can say, okay, well, 28.3 minus 12.6, that equals 28.3 minus 12.6, and that gives us 15.7. Now, if you want to be really cool, which we all do, especially when we're talking about maths, is what we could actually do is we could say, well, the area of the big circle is 9 pi, and the area of the small circle is 4 pi. So 9 minus 4 pi. Choose a new one. 9 pi minus 4 pi. Well, that's 5 pi, which we can just put in our calculator, and that gives 15.707. So same answer, 15.7, and that's already to three significant figures. Yay! Calculate the circumference of the path, the outer circumference of the path. Formula sheet tells us that the circumference is pi d, where d is the diameter. Okay, so if I've got my circle like that, what's my diameter? What's the diameter? Well, we know that that's 3. That's also 3, so the diameter must be 6. So pi d equals 6 pi, which is 18.849 ... and to three significant figures, that's 18.8. Look at the second, look at the digit after the third significant figure. If it's a 4 or less, it doesn't change. If it's a 5 or more, it rounds up. That's correct. So 18.8 there. Done. Number 6, calculate the value of A. This is trigonometry. I'm going to write SOHCAHTOA. My mnemonic for this is silly old hens can't always have tons of acorns. I was taught that by my maths teacher in year 8, and I've never forgotten a bit. Anyway, so I look at what I've got. I'm going to label my sides. Always, the diagonal is the hypotenuse. The one next to the angle, which is not the hypotenuse, is the adjacent, and the other one, or the opposite, is the other one, aptly named O. So I look which one I've got. HOA, there, OH. Okay. Sine, that's going to be our angle. So I know that sine of A equals opposite over hypotenuse. My hypotenuse is 7.1 and my opposite is 2.5. Okay, now if you remember back to the thing we did last time in the previous paper, I am now going to have to get rid of this sign. I can't divide, I can't take it away, but what I can use is the inverse sign. So on my calculator, I'm going to click Shift Sign. So that gives me something that looks like sine inverse. That's what that negative one is, inverse. Sine inverse of 7.1 over 2.5, that equals A. So in order to get rid of this sign, we take the sine inverse of both sides. So that gives us sine inverse of 7.1 over 2.5, and that equals A. So let's do that, 7.1 over 2.5. Hey. Oh, there you go. Always check your working, kids, because I put that in my calculator and the calculator says math error. Okay, and I realize what I've done is that I haven't put this in correctly. The opposite is not 7.1, it's 2.5. And the hypotenuse is 7.1. Aha. What a crazy man. So I'm going to do this in a different color. Not that one, not that one. It's 2.5 over 7.1. Okay. Right, where were we? 2.5 over 7.1. Aha, much better. That gives us 20.6165, blah, blah, blah. To three significant figures, 20.6. I look at the next one. It's 4 or less, so it stays at 20.6. Okay. The next one, I'm going to skip this one for the. No, I'll do it. This is called sets. And what it means is that A is just a collection of numbers. It's completely arbitrary. You can choose a set to be a collection of anything. A set could be the things in the world, all things that are white. Okay, so anything that is white, you could find in that set. You can do it with things, you can do it with numbers. You could have something like days of the week, etc. So it's just a collection of different things, really. So in here, A is a set, just the name of the set. Can be anything you want. It could be B, C, D, E, F, whatever. And it contains 4 elements or members. And B also contains 4 elements or members. Now, this little guy here, that's the union. That means something that is in A or B. Okay, anything that could be in A and anything that could be in B. So anything that's in A is 1, 2, 3, 4. And anything that's in B, well, I've already got the 2, so I'm not going to write that. I've already got the 4, so I'm not going to write that. But I've also got 6, and I've also got 8. So if it's in A or B, that includes everything. So now this here is a new set, okay? So A union B equals this, okay? Just a new collection, that's all, nothing fancy. Here it says write down the members, so I'm just going to write them down not as a set, 6, 8, okay? Now, I'm just going to touch on something really quickly here. A intersect B is where it's in A and B only at the same time. So in here, I can see that the only numbers that are in A and B are 2, 2, and 4, 4. There's nothing else which is in A and B. So this would be just 2 and 4. This funny looking E sign is what we call the universal set. It just means everything that we are talking about. Normally for numbers, we just say it's all the numbers, possibly. It could be, the universal set could be the set of numbers 1 to 10, okay? P equals, so here we've got positive integers less than 10. So here, the numbers that we've got are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Not including 10 because it's less than 10. Not including 0 because it's positive. Integers meaning whole numbers. P is 3, 4, 5, 6, 7, 8. P intersect Q is this thing here. This just means the empty set. So if I took my examples from here, right, and I said, let's call this, I don't know, M and this N. If I do M intersect N, how many days of the week are white? None, because it's stupid. So this is what we call the empty set. There's no overlap, okay? So here it says P intersect with Q is the empty set. Write down all the possible members of Q. So P is 3, 4, 5, 6, 7, 8. Well, Q cannot be any of these numbers, but it could be any of that one, or that one. Everything outside of P. So write down all the possible members of Q is 1, 2, and 9. Okay, a very, very whistle-stop tour of sets. Okay, let's have a go. Jim fires an arrow at a target. The target shows all the possible outcomes and the probabilities of 3 of these outcomes. Okay, bullseye, inner ring, outer ring, and miss. Bullseye meaning right in the middle. Work out the probability that his arrow will hit the bullseye or the inner ring. Now, that word there, or, this is something you just got to remember, or plus. If it's and, you times, okay? You add probabilities when it's or, you times them when it's and. You don't have to know, you don't have to worry why. Now, all of these are all of the possible outcomes, okay? So there must be 100% probability, 100% probability that one of these things happens. So it's either going to miss or an outer ring or inner ring or a bullseye. So if the probability is going to be 100%, well, in probability terms, that's one because we use decimals, and one as a probability, so one as a percentage is 100%. Okay, so I know that these four added together, because it's or miss or outer ring or inner ring or bullseye, must equal 1. So I need to work out what the bullseye is. So I'm going to do 0.2 plus 0.4 plus 0.3 plus something equals 1. Well, 0.2 plus 0.4 is 0.6 plus 0.3 is 0.9 plus x equals 1. So I know that x equals 0.1. And I'm going to put that in there. And that makes sense because the probability is lower of getting a bullseye. Now here it also says, work out the probability that Jim's arrow will hit either the bullseye or the inner ring. All right, no problem. Because it's or, I know that I need to add them. Bullseye, 0.1 plus, because it's or the inner ring, 0.3 equals 0.4. So my answer is 0.4. Done. Next, 9. Expand. Whoa, nice one. 4 times that and 4 times that is 4v plus 12. Easy. 1 mark. Boo. Simplify this. Now, you've got these things called indices up here. What does that mean? It means W times W times W times, that's the W to the third power, and W times W times W times W times, oh my God, 1, 2, 3, 4, 5, 6, 7 over W times W. Okay, well, when you've got times in the numerator and the denominator, when you've got common factors, you can actually cancel them out. I think you should remember this. Right? It only works with timesing though. It doesn't work with addition. So if I had W plus V over W, that does not work. No. Only with timesing. So what am I left with? Well, I'm left with W times 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 W, which is 1, 2, 3, 4, 5, 6, 7, 8. So that there is W to the 8. Now, the simple way of doing this, because nobody wants to write out all those W's, and plus, the question could be something like simplify W to the 35 times W to the 27 over W to the 15. And nobody's going to write all that stuff out. But what did we do? Well, if you've got W to the 3 times W to the 7, well, all we do is just add those two indices, right? That's W to the 10, which is what we've got in the numerator right over here, okay? So we do that, and then what did we do? Well, we took away 2 of those W's from the denominator because of the denominator when we're cancelling out. So what happens with something like this? Well, we're going to have W to the 35 plus 27 over W to the 15. Well, that's W to the 35 plus 27. 35 plus 27 is 62. W to the 62 over W to the 15. And then 15 of these 62 W's are going to be cancelled out by this denominator. So we're going to get W to the 62 minus 15. W to the 62 minus 15. which is 62 minus 15, it's 47, equals w to the 47. So that's the quick and easy way of doing it. Okay, 8. Solve the equation. Okay, 17 minus x over 7 equals 3. That's quick maths. 17 minus x, I've got this in the denominator. I'm going to times by 7 to get rid of the thing in the denominator. That equals 7x. Then I want all my x's together. I'm going to add x, collect my terms, 8x, and then I'm going to divide by 8. Ooh, divide by 8, and I get 17 over 8 equals x. And I'm just going to check that really quickly. I'm going to do 17. I just put it literally, it's going to write it into my calculator, not with x. I'm going to put 17 minus 17 over 8 all over 7, and that should equal 17 over 8, which it does. So I just check that in with my calculator really quickly. Solve the inequality. The inequality here just means 4y minus 5 is less than x. Treat it like a normal equation. So I'm going to put 4y minus 5 is less than 0 and do the same thing. So I'm going to plus 5 to both sides. 4y is less than 5, and I'm going to divide by 4 on both sides, and I'm going to get 5 over 4. So y is less than 5 over 4. Last one. The table shows the carbon emissions sorry, hang on. There we go. Right. The table shows the carbon dioxide emissions in tons produced by each of 4 regions in 2001. Okay, which of these regions produced the lowest carbon dioxide emissions? Well, I'm going to look at these numbers here. Now, you might be tempted to go, well, 1.4 is the lowest, but look, over here we've got times 10 to the power of 9. Here is 10 to the power of 8. So actually, Africa made the lowest. It's the lowest number, Africa. Work out the total carbon dioxide emissions produced by these 4 regions. Right, the total, I'm just going to add them together. Literally, I'm just going to add them in my calculator. I'm going to do 5.7 plus 5.7, and in the middle of the calculator at the bottom there should be a times 10 to the power of x button, and on your screen it should look like a times little 10, and then you just put in the number of your of this thing up here. So my calculator for this one looks like 5.7 times 10 7. That's what my calculator looks like. And then I'm just going to add the others. 8.4, 8 plus 1.4 times 10 to the x, 9 plus 3.2 times 10 to the x, 9. And that gives me, now, on my calculator, that's 5497. And then I've got 6 zeros. 1, 2, 3, 4, 5, 6. All right. So now it says to give my answer in standard form. This up here, that is standard form, where you've got a number between 1 and 9, or it could be a decimal, it usually is a decimal. So you can't have something like 0.5 at the beginning of a number in standard form, and you can't have a number over 10. When you're doing standard form. Those are big no-nos. So it's got to be between 1 and 9. So if I look at my first digit is a 5. So I know that in standard form it's going to be 5 point and then write everything else. 497. Now, all of standard forms, they have a times 10 to the power of something. So it's going to be times 10 to the power of something. Question is, what? Well, can you count? Yeah, I can count. I put a decimal place there, and I see how many places it's got to go to get to where I need it to go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 decimal places. And then, bing bong, 9 there. So we're almost there, but it says 3 significant figures. So I look at my first one and my second one and my third one. Those are my significant figures. I look at the next one. That is a 7. So this here, this 9 is going to round up. So it's going to round up to a 0. Well, 49 is going to round up to 50. So it's going to be 5.5. Now, importantly, you've got to put the 0 there, times 10 to the 9. 5.50 times 10 to the 9. Right, here. Oh my goodness. Looks scary, not scary. This here is just a number. So I'm going to do 1.4 times 10 to the 9 equals k times 8.4 times 10 to the 8. I'm going to divide both sides by 8.4 times 10 to the 8. Divided by 8.4 times 10 to the 8. That there gives me, on my trusty calculator, fraction 1.4 times 10 to the 9 over 8.4 times 10 to the 8 equals, oh, look at that, 5 over 3 equals, so k equals 5 over 3. It doesn't say like decimals or anything like that, so I'm just going to leave it as 5 over 3. And that's it. I hope you've enjoyed this as much as I have. See you later.